The second problem in Chapter 9 is very similar to the media selection problem. We're doing more marketing analysis, marketing campaigns, and in this case, we're doing a survey, and we're going to gather information from households. Let's just take a look at the problem. So, Market Survey Incorporated, MSI, for short, specialize in evaluating consumer reaction to new products, services, and advertising, blah, 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 blah. During meetings with the client, MSI has agreed to conduct door-to-door personal interviews to obtain responses from households with children and households without children. Okay, so that clearly is important. We're going to have two different types, with children, without children. In addition, MSI agreed to conduct both day and evening interviews. Okay, so we have with children, without children, evening and day. So we have with children, day, with children, evening, without children, day, without children, evening. I already have 4 unknowns there. The client contract calls for 1,000 interviews. So, okay, I already know that the sum of those 4 cannot be more than 1,000. So it's going to be children day plus children evening plus without children day plus without children evening equals 1,000. Okay, I have to look at later. I'm not so sure if it has to be at least 1,000 or no more than 1,000. But for now, I think it says it has to be equal to 1,000, exactly 1,000. I think that's the case. Then we're giving some additional constraints. Interview at least 400 households with children. Okay, interview at least 400 households without children. Okay, the total number of households interviewed during the evening must be at least as great as the number of households interviewed during the day. Okay, so we're making a comparison between the nighttime and the daytime, regardless of with or without children, but there's some kind of comparison here. Okay. At least 40% of the interviews for households with children must be conducted during the evening. Okay, so 40% of the total of children with children households must happen during the evening. Okay, and then 60% of the households without children must be conducted during the. 60% of the without children must be conducted during the evening. Okay, because the interviews for households with children take additional, so apparently it takes longer to do the interview with children than without children. I wonder why. The cost of the interviews varies by that fact, whether you have children or not. So we're given data here about the cost, so you can see. With children is always a little more expensive than without children, with no children. So it's $20 for day, children day, $25 children evening, $18 for no children day, and $20 no children evening. All right, so I guess that's it. We only have 4 unknowns, which I already mentioned before, and our objective is to set a interview strategy with the lowest possible cost, obviously following this constraint. So our objective is going to be to minimize the cost. So the cost is going to be given by 20, which is the cost of children day, times the amount of interviews conducted in households with children during the day, plus 25, which is the cost of children evening, times the number of children evening interviews, plus 18, which is the cost of no children during the day, multiplied by the number of interviews with no children day, and then finally plus 20, which is the cost of no children evening, multiplied by the no children evening number of interviews. Here are constraints. These are a little bit funky at the end. So the first one is the easiest, which I already mentioned, right? The sum of all of them has to be equal to 1,000. That's an easy one. Then we are told up here that you need to have at least 400 of each of the two kinds. Okay, so children during the day plus children during the evening greater or equal than 400. And then without children during the day plus without children during the evening has to be also greater or equal to 400. For the next, we need to do some computation, just playing around with the formula. So number 4 says that at least as many evening interviews as day interviews. So EC plus ENC, which are the interviews during the evening, the sum of those two must be greater or equal to the sum of the daytime interviews, DC, DNC. Now, in this format, the way we have it here, you can't use that in Solver. So you need to manipulate this equation. You need to move everything to one side. So if you move DC and DNC to the left side of the equation, right, you get minus DC plus EC minus DNC plus ENC greater or equal to 0. That's how you end up with that. Let me know if that's not clear to you how I did that. I can help you out with that. But it's a simple algebra, moving the unknowns around. And then number 5, at least 40% with children in the evening. Okay, so EC, evening children, has to be greater or equal to 40% of the daytime children plus the evening with children. So 40% of the sum has to be, 40% of that sum, evening interviews must be greater or equal to 40% of that sum. Again, you play around with the math, and you end up with negative 0.4 DC plus 0.6 EC greater or equal to 0. Let me know if that confuses you, and I can do it step by step. And finally, we have the kind of the same situation, at least 60% without children in the evening. So evening without children has to be greater or equal to 60% of the sum of DNC plus ENC. If you rearrange the terms, you end up with negative 0.6 DNC plus 0.4 ENC greater or equal to 0. Right? So we build our solver here. So I have DC 20, EC 25, DNC 18, ENC 20. That comes from your objective, right, up here. And then we're going to take a look at our sum product to make sure. Yeah, sum product looks good. It's multiplying this range times that range. And then I have my constraints, not that many, only 6. So I'm going to take this data up here, and I'm going to put it down here. So 111 equals to 1000, right? Because it's 1 DC plus 1 EC plus 1 DNC plus 1 ENC equals 1000. So on and so forth. This is where you have to be a little careful. Be careful with constraint number 4, because you also have a couple of negatives there. And here you have negative 0.4, 0.6, and negative 0.6, and positive 0.4. And these are 1, 2, 3 greater or equal to 0. Yes, that is correct. Then you build your constraints. Let's take a look. So this range times that range. Yep, looks good. I'm going to check the last one. Looks good. Since I always drag, all I do is I check the first one and the last one. If they look good, that means that the ones in the middle should be okay as well. Now I'm going to look these guys here, the right hand side, 1000, 1000, 400, 400, 400, 400. Interesting, that font is different. Okay, 400, 400, that font is different as well. Okay, 0, 0, 0. Okay, now we go to solver. All right. So set the objective. Our objective is right here in C37, and we're going to minimize by changing these variables right here, and then I enter my constraints. 1, 2, 3, 4. Simplex. Okay, looks good. Make on remember the non-negativity. Simplex. Solve. Okay. And that's your solution. You're going to conduct 240 daytime with children, 160 evening with children, 240 daytime without children, and 360 evening without children. That is going to be, it's going to cost you 20,320, which is the minimum cost to the minimum cost in order that you're going to incur in order to meet all of these criteria. And that's it.